The very first topic we'd like to mention is about static analysis. Okay, so we will have a new slide for this one. There are two different types of analysis. One is called static analysis. The other is dynamic analysis. What does that mean? Basically, when we analyze malicious software, or in short, malware, maybe sometimes, okay, you receive a spam mail which has a file attached in the email, and you simply download it to your computer, and maybe you execute this malicious software, and then this malicious software tries to do something harmful to your computer. For example, steal your files, read your email, or try to modify your system configuration. Maybe they try to steal your contact information in your Outlook. Basically, malicious software can do whatever it wants to do as long as these execution steps are already written in the malicious software. So basically, how a software being developed, for example, in Windows, write your program in C, C++, C#, Java, Python, and so on, so any other language hacker would like to use. And then they have to compile his or her program into executable files. In Windows, which is .exe file, or in Linux, ELF file, which is executable file in Linux. So that this file can be distributed to the victims, and victims might accidentally execute those malicious software. For some security company, they will collect those executable files and do some research. If I can make a model which is a classified, and then if you give me a new malware sample and I feed this malware sample as input to the classifier, and if the classifier is very good enough and the classifier will say, okay, let's do a binary classification, either 1 or 0, which means yes, it is a malicious software, or no, it is not a malicious software, it's a normal software, so you can use the software. So basically, the very first classifier we'd like to build right here is, if we can build a classifier, okay, based on the model we learned before, the malicious software file as the input, and we select a lot of different features from that file, and we try to make a model, and our target Y is 1 over 0. It is a malicious file or it is not a malicious. So the very first thing right here is, how do we decide which kind of features we would like to extract from execution file? Maybe it is a very normal file. For example, you have Word, you have Excel, you have Outlook, something like that. So that we have to define several different features that help us to distinguish normal files and malicious files, which is malware. Let's take a look at this slide, okay? Right here. You can execute, you can download, you can make a copy of this file to your own Colab and try to analyze your own files. Okay, the first step. .exe file that I use is a normal file because at this moment I don't want to share any malicious file to you, because you might accidentally execute it in your own computer, and your computer will be infected by the virus or by the worm. So currently in this example, I only use normal file as an example. Okay, the file I use is right here. So the very first thing is that I would like to download normal file from internet. This is called PuTTY. PuTTY is a very simple and very small Windows executable file. Again, you can download from the internet. They guarantee it is a normal file. We simply just use it. Okay, you have to make sure line number 2, wget means I would like to download this file from the internet. So here's the URL, and big O minus O means I have to output this file as putty32.exe. So your Colab will download this file. Don't forget that here is a mark right here. After you execute this cell, your Colab will download this file for you and put this file in your Colab repository. It will not store in your Google Drive. No, it will be downloaded to your Colab repository. If you close your Colab, this repository will disappear. So every time you want to try this program, you have to download it again. Okay? 好，中文再讲一遍，就是你可以下载这个东西嘛，然后复制到你的 Colab 里面去嘛，哈，然后你下了这个指令哈，就是惊叹号 wget， 然后后面一连串是网络上的东西 ，big O 是输出之后，你的 Colab 会去下载这个东西到 Colab 的 repository 里面。 而这 repository 是 runtime 的，也就是说它只有在那一瞬间会存在而已。如果你把这个 codec 关掉的时候，这个档案就不见了，而且这个档案不会存在你的 Google Drive 里面哦。你要记得这件事情哦。所以每一次你在做这个实验或是做这个分析的时候，你第一个 cell 一定要再重新下载一遍。Okay, that is the first cell. Okay, the second cell. Since we know we have 32-bit CPU and 64-bit CPU, so I download another file which is footage62.exe. So I like to show you what is the difference between 32-bit execution file and 32-bit execution file. So after that, we have two files. Okay, you can simply just execute ls, which means list all the files that I download from the internet to the Colab repository. Again, this repository will be removed, will be deleted after you close your Colab. Okay, so every time you want to analyze these two data, you have to download it again. exe file is defined, of course, by Microsoft because it's a Windows execution file. So how do we know that it's an exe file? Very simple. You can simply just write a function and to see if this file ends with .exe. But however, that's very straightforward, right? But it's very stupid function because malicious software maybe it can do evasion. Evasion 就是隐藏啦哈，知道这个方向超笨嘛，就是看那个结尾是不是 exe 嘛，对不对？那你以为恶意程式有这么笨吗？哈，把自己的结尾弄成 exe 嘛，那当然会换一个名字嘛。So that's a very stupid function. Most of the malware knows, okay, you will check if the execution file ends with exe. So they can change it to, for example, .doc, .exls, .pdf, something like that. 反正他们不会那么笨嘛，他们也会换副档名嘛。So that is a very stupid function. But how do we know it is exactly a exe file or not? So let's go back to our slide. Here we have a entry called Windows Proto File Format. Okay, we have two different reference, one for Wikipedia, one from Microsoft. Okay, you can simply click the Wikipedia on this one. Wikipedia page, it describes it should be formatted as follows. Okay, so let's take a look at figure. The title right here is the structure of a portable executable 32-bit file. So basically, if this file, you want this file to be executed in Windows, and if it is a 32-bit execution file, .exe file, your file format should be like this. There are several different sections, okay, in different colors right here. Huh? If your execution file does not follow this structure, then Windows will not execute this file. 好，就是说你的一个程式要在 Windows 上被执行，那一定要符合某个规范，那个规范就在这边。好，如果你的 file 的格式不是长得这个样子 ，Windows 是不会帮你执行，好吗？所以我们现在是要稍微看一下这个格式里面有什么东西。Okay, so let's take a look at what information has been included in this format. Okay, this format usually we use a word which is PE file. PE stands for portable. E stands for most of the Windows.exe file belongs to this format. So sometimes we use, okay, it is a PE file. So it looks like a packet. 它跟那个网络的封包很像。There are several different headers and there are several different payloads. Okay, for the first few bits, since we know before Windows you have those operating systems, so those files inherit from those. Okay, there are several headers which can be read by DOS OS. So we still keep these headers. The first 2 bytes, which is 16 bits, it should be 5A4D, that is 2 bytes. If you are familiar with hexadecimal system, 就是如果你对16进位的系统有点了解的话 5A4D 就是2个 byte， 一个 byte 是用2个16进位的数字表示嘛，所以 5A 是一个 byte， 4D 是一个 byte。If the very first 2 byte is 5A4D, okay, of course in hexadecimal system, then that is the signature of the PE file. Okay, and then there are several different DOS headers, and of course there are several information that DOS need to use. Them is the DOS stuff. There is a additional 4 bytes pointer which points to the next section, which is the P header. So the blue ones, the blue headers belong to those headers, and there's a signature at the first 2 bytes, which is 5A4D. And at the end of those header, there is a 4 bytes pointer point to the next section, which is PE file section. Okay, and the PE file section, it takes, okay, just take a look at this one. It has a 4 bytes signature, which is 5045000. This 4 bytes indicates that all the file-in sections belongs to PE headers, and so on and so forth. Let's take a look at some data field in these PE headers, because I think that's important for analyze the malware. 就刚讲嘛，前面有一个 DOS header 嘛，然后有一个 pointer 4 byte 会指向第一个这个 PE file 的这个区段，就是浅绿色这个区段啊。那我们通常是认为说呢，浅绿色啊，后面那个肤色啊，然后后面那个粉红色的区段里面，应该有一些东西是很有价值。有价值什么？有价值来让我们判断说，你现在看的这个档案到底是恶意程式，就是malicious software，还是它是只正常程式？正常程式我们说用 normal software， 或者我们用 benign 就是善良 benign software。我们不是说嘛，我们现在做一个 classifier 啊，那 classifier 有很多 feature 啊，那 feature 哪里来？就从这里面来，这里面有一些你从过去可能没有看过的一些 information， 而这些 information 可以帮助你去判断它到底是坏程式还是好程式。Okay, our goal is to build a model which contains a lot of different features that help us to distinguish malicious software and benign software. Right? So here in the PE file, there are a lot of headers: the light green ones, the orange ones, the pink ones, the blue ones. We believe there are some variable information can be extracted from those headers and help us to build the features. And we use these features to build a model to help us to distinguish benign software. So we have better to understand what is the information inside those headers. Okay. Next one is machine. What is machine means? Machine means this execution file is built for 32-bit operating system, or it is built for 64-bit operating system, or it is built for some other operating system. We use 2 bytes to specify what machine, what operating system this executable file is built for. Okay, and then number of sections. That means how many different colors. Okay, right here. How many different colors? Right here. This file includes. Okay, date timestamp. That means what is the date time that this file has been compiled by the compiler. 就是这里会有一个时间的戳记，就是你现在这个执行档啊，当初被 compile 的时候是几年几月的几点几分的时候被 compile 出来的。Of course, this data field can be forged. You can simply just put a random number right here so that the user receives your execution file and they cannot recognize when and what date this file has been. 在这个 header 里面呢，虽然有这个栏位，可是你也可以乱填。你随便填一个数字进去啊，你就不想要让你接收，不想要让你的使用者知道你什么时候 compile 这些程式的，对不对？所以你随便填。Okay, there's a symbol table, but we don't use it anymore, so we just simply skip it. Size of option headers. That means how many additional headers. Okay, right here, right here, right here. Okay, there are some other important things. We will not go over all the fields. Okay, I'll just simply pick some of the important fields right here. For example, the size of code. Since it is a program, so you write C, C++, Java, Python, no matter what, you just compile it to machine code like this. The machine code is arranged in PE file format. So the size of code means how many codes in machine code. I think it's byte, okay, in byte. Size of initialized data, the size of uninitialized data, okay? You have several variables when you write program, right? So how many data has been initialized and how many data has not been initialized. How many headers you have, okay? What is the checksum, okay? If you have learned how to analyze a packet, I think you already know what is checksum, what checksum is. There are several tables right here. When you execute your program. There are several variables, global variable functions. The compiler helps you to build several tables so that there are a lot of entries. Okay, each entries represent where you put this variable, where you put these functions, where is the global variable, where is the for example images or resources, okay, strings or those variable X, and where you can find your library, or you provide several libraries, several functions to other programs, to other executable files. Okay, so there will be a lot of files right here, so on and so forth. We will go back to this view graph later. So basically, if you would like to know this file is really an PE file, or if it's just a fake file, but it has a .exe extension file name. If you want to know this, that stupid function does not work. You do this one and this one. Because, as the figure says, normal PE file should have a DOS header and should have a PE file header. So we can simply check if the first 2 bytes of this file, okay, so let's take a look at this one. If the very first 2 bytes is 5A and 4D, right? 5A and 4D. In program, it is simply just 2 characters, which is big N and big Z, capital N and capital Z. Then we say, okay, you have the correct signature. And the second one, then you continue. If the first 2 bit is capital N and capital Z, and then you seek, which means you have a pointer. Try to seek this PE file. Where is the 3C? 3C means we are seeking what? We are seeking right here. Do you see that? We are trying to figure out where is the pointer. The pointer is in a fixed location in this PE file, which is written here, 3C. So that we can make our pointer to point to the 3C location right here. Okay? And we read 4 bytes to get the values pointer so that we can jump to the very first byte of PE header. So that is, we jump, so that is jump. We jump to the location of 3C and we read 4 bytes. And then we further jump to the location where the 4 bytes point to. And then we read further 4 bytes and to see if it matches certain signature. So that is, we read this 4 bytes and we jump to the location pointed by this value to here, and we further read another 4 bytes and see if it matches to this magic number, this signature, 504500. What does that mean? We further jump to this 4 bytes, and if it matches to capital P, capital E, and 2/0/0, that is exactly, the capital P is 50, the capital E is 45, and that is 00, that is. So this function is much smarter because it exactly follows the data structure, the structure of PE file, and to check whether the signature is exactly the same, okay, which is MD and the PE 00, so that we can verify that is indeed a PE file. For example, Windows operating system, before they execute your execution file, they do the same check. If your file does not follow this structure, Windows will not execute it. Okay, so that basically we use this single file. We can check if this file is a PE file or is just a, for example, a PDF file. The next one, as we mentioned before, is the machine. Machine is right here. So we have another 2 bytes. Okay, so let's go back to here and we see, okay, we like to check the further 2 bytes. That is the same. The above one is the same. So we further read another 2 bytes. So that is machine. If this number is 332, and that means it is a 32-bit x86 machine. This file is for 32-bit x86 就是如果你在 machine 那边读出来的值啊，如果它是332数字的332的话，表示说当时在 compile 的设定的时候啊，这个执行档就是为了那个 x86 的32位元的 CPU 制作。Of course, there are some other values right here. And how do we know which number maps to which machine? If you click this one, Microsoft PE file format. You can figure out. And there are several tables. Still, they are talking about the structure of the PE file. Okay, of course, we have MS-DOS headers. As we mentioned before, it's big capital M and capital Z, right? We have several different values right here. We have P headers. So for each one, we have a very detailed explanation of each field and what is the value in this field means. So here, machine types, if this value is right here, A664, and that means this compiler is a X64 compiler. So this file can be run in 60-bit CPU and operating system. Okay. Of course, there are some other CPU. For example, with the ARM CPU, which is used by your cell phone. We have ARM66 CPU. For example, your iPhone might belong to this one. And we have a legacy Intel 32-bit CPU, something like that. We have MIPS, we have a lot of CPU. So this structure, PE file structure, okay, is not only for Windows. They can be used on other machines. Okay, so you can simply check these values. Okay, we have a table, mapping table right here. So basically, you can extend this if and else. Okay, try to map all the values defined by Microsoft, so that we can simply just execute this function on our download PE file, which is PE32. So then we can say, okay, it is a 32-bit file, and for PuTTY 63, in that field, it should be this value. Right? And for the PuTTY 32, this value should be 332. It's quite straightforward. Okay, just take a look at the definition from Wikipedia or Microsoft's page. Okay, it describes how many fields they have, what is the value in this field, and you simply just read those fields from the execution file, and then you know, okay, then it is either 32-bit file or 62-bit. What's next? After we do those parsing, we can simply just print all the fields by using hexadecimal system. 就是说，其实你也不管啦，你拿到一个档案之后啊，你就可以简单的把它用16进位的方式把它印出来了。So that we provide a function that can help you to print hexadecimal. So that we can see that these two parts, right? 4D5A, that is MZ, right? That is DOS header. Here, that is PE file header, right? And so on and so forth. And I believe that one is machine, and so on and so forth. So you can do such kind of mapping by yourself. Basically, we will use most of the information right here to extract them as the features. We will teach you which field is more valuable when you want to create a classifier to classify malicious software and benign software.